NENOMATICA, where mathematics meets YouTube excellence. In this proof, we will rigorously show that the floor of x minus the floor of x, all inside a floor, equals 0 following a clean, step-by-step structure. We begin by stating the theorem, and then proceed with a short and precise proof. Step 1. By definition of the floor function. If the floor of x equals n, where n is an integer, then n is less than or equal to x, and x is less than n plus 1. From that definition, it follows immediately that n is less than or equal to x, and x is less than n plus 1. Step 3. Substitute n with the floor of x in that chain of inequalities. Step 4. Subtract the floor of x from every part of the inequality to isolate the expression x minus the floor of x. Step 5. Simplify each part. The left side becomes 0, and the right side becomes 1. Therefore, 0 is less than or equal to x minus the floor of x, which is the floor of x, which is less than 1. Step 6. If a number lies between 0 inclusive and 1 exclusive, its floor is 0. Therefore, the floor of x minus the floor of x equals 0. If bracket x minus bracket x bracket equals 0, then the quantity inside must be greater than or equal to 0 and strictly less than 1. Step 2. Derive the standard floor inequality. Add bracket x to all parts of the inequality 0 less than or equal to x minus bracket x less than 1. This yields bracket x less than or equal to x, which is strictly less than bracket x plus 1. Step 3. Derive a bound directly for bracket x. Start again from 0 less than or equal to x minus bracket x, which is strictly less than 1. Subtract x from all parts to get negative x less than or equal to negative bracket x, which is less than 1 minus x. Multiply by negative 1, remembering to flip the inequality signs. Then reorder from smallest to largest. Notice how the number line picture matches each statement. In this lesson, we will prove a clean identity mixing floors and logarithms. Here is the statement we want to verify for x greater than or equal to 1. The floor of log base 2 of x minus log base 2 of floor of x equals the floor of log base 2 of x minus the floor of log base 2 of floor of x. First, consider the case when x is less than 1. In this situation, the floor of x is less than or equal to 0, so the expression log base 2 of floor of x is undefined. Therefore, the identity is only meaningful for x greater than or equal to 1. We will work from here on with x at least 1. Now, assume x is at least 1. Let log base 2 of x equal n plus p, where n is an integer and p is the fractional part with 0 less than or equal to p less than 1. This means the floor of log base 2 of x equals n. A fundamental property is that the floor of x is less than or equal to x. Since the logarithm base 2 is an increasing function, we have log base 2 of floor of x less than or equal to log base 2 of x, which is n plus p. Next, because n is the floor of log base 2 of x, we know 2 to the n is at most x, which implies floor of x is at least 2 to the n. Taking log base 2 gives log base 2 of floor of x at least n. Altogether, n is less than or equal to log base 2 of floor of x, which is less than or equal to n plus p. Now multiply the whole inequality by negative 1, which reverses the inequality signs. Then add log base 2 of x to every part. Finally, substitute log base 2 of x equals n plus p and simplify. Because the fractional part p is at least 0 and strictly less than 1, the entire expression log base 2 of x minus log base 2 of floor of x lies between 0 and p, which is less than 1. Taking the floor of that gives 0. Now compute the right-hand side. The floor of log base 2 of x equals n by definition. And since log base 2 of floor of x is between n and n plus p, its floor is also n. Therefore, the difference is n minus n, which is 0. Therefore, both sides equal 0 for all x greater than or equal to 1, while for x less than 1 the expression on the left is not defined. Hence, the identity holds on the natural domain x at least 1. Intuition: since floor of x is at most x and at least 1, the ratio x over floor of x lies in the interval from 1 to 2, so its log base 2 lies in the interval from 0 to 1, and the floor of that is 0. Welcome! In this example, we will find the range of the function y equals x minus n times the floor of x over n. We will proceed step by step using the key property of the floor function. Step 1. Recall the key property of the floor function. For any real x, x minus floor of x is always between 0, inclusive, and 1, exclusive. Step 2. Rewrite the function so that the pattern looks like x minus floor of x. Factor out n to write y equals n times parenthesis x over n minus floor of x over n close parenthesis. Step 3. Apply the rule with x replaced by x over n. That gives 0 is less than or equal to x over n minus floor of x over n, which is less than 1. Step 4. Now multiply the entire inequality by n. We will assume n is a positive constant. Then we obtain 0 is less than or equal to n times parenthesis x over n minus floor of x over n close parenthesis, which is less than n. Step 5. The expression in the middle is exactly y. Therefore, the range of y is all real values from 0 inclusive up to n exclusive. Important note, if x is restricted to integers and n is a positive integer, then y becomes the remainder upon division of x by n, and the only possible values are the integers 0 through n minus 1. Now, let us build visual intuition with a concrete choice. Say n equals 5. The range is from 0 inclusive to 5 exclusive. We will slide x and watch the value of y equals x minus 5 times floor of x over 5, which behaves like a sawtooth, always staying between 0 and 5. Summary. Using the floor property x minus floor of x is in the interval from 0 to 1, we rewrote the expression and concluded that y equals x minus n times the floor of x over n always satisfies 0 less than or equal to y less than n, assuming n positive. If x is an integer and n is a positive integer, then y can only be the integers 0 through n minus 1. Final answer. The range is all real, y such that 0 is less than or equal to y, and y is less than n. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.